The Pythagorean theorem is probably something we've seen in the past and we're pretty comfortable with. So let's just kind of quickly go over, review it, and maybe understand one or two new things. But the purpose of the Pythagorean theorem, and it's been around for a very, very long time, is basically when you have a right triangle, it has to be a right triangle, you can take the square of the two legs, the legs are the sides around the right triangle, and it has to equal the square of the hypotenuse. So in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Basically, the two sides that make up the right angle, square them both, add them, and that has to equal the hypotenuse squared. A and B you can kind of switch around, it doesn't matter, but C, the hypotenuse, that's important. It's always across from the right angle. Now maybe something you haven't seen before is, get a different color here, a Pythagorean triple. And it says a Pythagorean triple is a set of three positive integers, and that's what I want you to focus on. It's a set of three positive integers, a, b, and c, that satisfy this equation. We're going to come up with numerous different numbers that satisfy this equation, but to be a Pythagorean triple, they have to be integers, positive or negative whole numbers, including 0 for a lack of a better term. So let's look at an example, okay? Find the length of the hypotenuse of the right triangle. Again, here are the words right triangle and length. You should automatically think Pythagorean theorem. Now I traditionally write it as a squared plus b squared equals c squared. No different than c squared equals a squared plus b squared. Whatever you're comfortable with. So we're looking for our hypotenuse, our c. Call that x. And then we'll just go 15 squared plus 8 squared. Again, it doesn't matter if you did 8 squared plus 15 squared. 15 squared is 225, plus 8 squared is 64. And that works out to be 289. Now, the answer isn't 289. The answer squared is 289. So undo squaring, we take the square root. Now when we do this, when we take a square root, remember there's a positive answer and a negative answer. What I mean is, the square root of 289 is 17, because 17 times 17 equals 289. But so does negative 17 times negative 17. Dealing with the side length of a triangle, we're not interested in the negatives. It really doesn't make sense. Okay? So we found our hypotenuse has a length of 17, but then it says, tell whether the side lengths form a Pythagorean triple. Well, what are our side lengths? 8, 15, and 17. Because they're all integers, this is a Pythagorean triple. Or you could say, yes, okay, but a Pythagorean triple because they're all integers. Now in this example, we are finding our hypotenuse, what it's equal to. In this one, it says find the length of the leg of the right triangle. Again, focusing on that this is a right angle, and to kind of help me identify, especially when they get turned around, what the hypotenuse is I usually draw an arrow for my right angle. A squared plus b squared equals c squared, or c squared equals a squared plus b squared. And I'm going to just say 15 squared plus x squared equals 20 squared. So that works out to be 225, I believe, plus x squared equals 400, and we just have to go through that and solve for our unknown, solve for our x. So I'm going to subtract 225 off of each side. That cancels, I'm left with x squared equals 175, but again we're going to take the square root of that, and we get x equals the square root of 175. Now, we want to keep this as exact as we can, but we want to simplify it. So if you remember simplifying, basically you look for a perfect square factor. 4, 9, 16, 25, any of those, that would go into here. And I just know that 25 goes into 175, because it goes into 104 times and 75 3 times. So I can rewrite the square root of 175 as the square root of 25 times the square root of 7, just breaking it down. And again, we're multiplying. The square root of 25 is 5, 7 isn't a perfect square, has no perfect square factors, so we get x is equal to 5 times the square root of 7. Now remember, another way to do this Maybe you're looking at 175 and you're like, you know what, I know 5 goes into that 35 times. And then you can break down 35 into 5 times 7. Remember, this is just the other method for simplifying. 175 is equal to 5 times 7. So if you want the square root, you circle the pair, pull it out front, and whatever doesn't get circled is under the radical. Same either way. So whether you think of it as pulling out perfect squares or you think of it in using the factor tree method, you get the same answer. And simplify it. Unless it says round to the nearest whatever, make sure you're writing these in simplest form. Now in this case it doesn't ask to see if it's a Pythagorean triple, but remember, to be a Pythagorean triple, they have to all be integers. This is not an integer, therefore it is not, or no, not a Pythagorean theorem. Or, I'm sorry, Pythagorean triple. Alright, one more example. Let's take this even further. It says find the area of the triangle to the nearest tenth of a square inch. Area of a triangle is 1/2 the base times the height. I have the base, it's 18. But I don't have the height. What I do have, though, is I know that this whole thing is 18, and it breaks this up, since this is 12 and this is 12, into an isosceles triangle. So maybe if I just focus on one side, I can use this information, just this triangle right here, I can use this information to find that height. And if I can find the height, then I can find the area. So, Pythagorean theorem, h squared plus 18 squared equals 12 squared. That's h, oops, mistake already. Hopefully you caught me. This whole thing is 18. It's being cut in half. That means 18 divided by 2, or into 2 sections, this has to be 9. So let's try that again. h squared plus 9 squared equals 12 squared. Just doing the calculations now. 9 squared is 81, 12 squared is 144. Subtract 81 off of each side. H squared equals 63, so this is going to be the square root of 63. Now, I could simplify this, okay, and I know actually I'll tell you that 9 goes into 63 and it's a perfect square, so it simplifies down to 3 square roots of 7. Even if you're not going to simplify it, though, don't round it to a decimal yet. Wait to rounding until the very, very end. That'll give us a more exact answer. So now, to find the area of a triangle, this triangle, it's 1/2 the base times the height. So we're going to 1/2 of the base, 18, times our height. Well, we just found out that our height is this 3 square roots of 7, or square root of 63. And since it says to the nearest tenth of a square inch, we can multiply all that together, and it's going to be approximately equal to 71.4. And these are measured in inches, so it'll be square inches. So again, we can use our Pythagorean theorem to find missing side lengths, and by finding those side lengths, then we can solve different problems, such as an area problem. Keeping in mind, this only works for those squared to the second power. It actually doesn't work to the third power or the fourth power. And if you find 3 side lengths that are integers, those are called Pythagorean triples.